Okay, week one, modes of interaction. So you'll notice there's an A at the end of the title. That means that it's not going to be the only lecture about modes of interaction. In immersive environments, in immersive design, there are infinite modes of interaction. So what is the actual goal of these lectures? We want to provide some anchor points to all these different interaction modes. Now, before we proceed any further, I want to first apologize that I'm just recording this in front of a screen, so it's kind of hard to pretend that there are people in front of me, and there's not going to be any feedback, so it's not going to be very dynamic. But I guess if you have any questions, just hold that thought, write the question down, and then ask the question in class, or maybe you can even post it in the forum. Now, I don't know about you, but I myself find it really difficult to learn anything if I were just to passively consume somewhat, someone is saying. So I'd really encourage everyone to engage. Given the limitations of online, we can engage asynchronously through the forum, and then I guess we can also engage synchronously when we have our face-to-face live classes. Having said that, our topic can get quite overwhelming just given the sheer volume of information that's actually out there. So let's try to simplify things as much as we can whenever we can find things to simplify. So, human dimensions? Well, we're actually interested in human factors. So if we just take one syllable out, human factors. So what are human factors? Well, it's things to do with people. So when we talk about immersive environments, we might end up talking a lot about technology or design, but all of that eventually need to interface with people. So that's when we have human factors. That gets really interesting and complicated because people are really interesting and complicated. But if we just keep taking it back to the human in our thinking of design, thinking of technology and everything else, that'll help us anchor ourselves, and what might have seemed overwhelming before ends up a little bit more manageable. So, modes of interaction. What are modes of interaction? And what does it mean to say modes of interaction in immersive environments? Well, a dude called Milgram created this reality virtuality continuum all the way back in 1994, and it's a pretty simple concept to digest, right? So on one end of the spectrum, we have what we usually experience, which is our real environment, and then if we go all the way to the other side of the spectrum, we have a completely virtual environment where nothing is real. And then somewhere in the middle, we have different levels of mixing of the two. So on this side, we have augmented virtuality. If it's a little bit closer to the virtual environment, but it still has some real world elements. And then as we move over to this side of the spectrum, we have augmented reality. And I guess in between there, we have what we would term as mixed reality. So that's not too bad, right? We can handle that. Well, if we actually look at some concrete examples of what we have these days, it gets a little bit complicated. So what I've done here is basically listed some of the things that are common across all the different modes of interactions. And then you can see here on the completely real part of the spectrum, we have live theater, LARP, which is like live action role-playing, theme parks, and restaurants. So these are immersive experiences that you can have just in the real environment. And then on the other side of the spectrum, we have things that you might have heard about in popular culture. So MetaQuest 2, I think, is currently the most widely available consumer-level virtual reality headset. You might have heard of Steam VR that's connected to your PC. Varjo, which is a little bit more high-end, super expensive virtual reality system. And then when we get to this side, where it's still a lot to do with reality, but it'll have some augmentation. So for example, heads-up displays of your car. So if you've recently bought a new car, you might have noticed that the windscreen or the windshield has some displays to help you navigate the environment a little bit better. Or I guess some people find it a distraction, so like they don't buy those kinds of cars, but they're pretty cool, I think. And then you might have heard of the much vaunted Google Glass from a decade ago almost. Now, I don't really expect you to know all of these things, but you might have heard of some of them. And we're not going to stick to this slide for too much longer, but the whole point of this isn't even the complete list of everything. It's just stuff that I put up, just things that I can think of off the top of my head. What can you think about off the top of your head, and where do you think it would land on this continuum? What's that? Did someone say Magic Leap? Yes, the Magic Leap. That's an augmented reality headset that would probably go somewhere around here. Yeah, sorry, I'm just pretending that someone's in the room with me. What about the new Pico 4? I guess that's like a competitor to the MetaQuest 2. That's a completely virtual reality headset. It covers up your entire view, and you don't see anything else other than virtual environments unless you do the pass-through, in which case it goes down here a little bit. The ACE Training Center here, that's a really cool example. I was super excited to actually visit that place over in Bankstown, and you guys will talk about that in 9901 quite a bit. Long story short, that's an excellent example of augmented virtuality or mixed reality, because you actually have real things mixed together with virtual things. So for example, one of their training simulations is a skeleton almost of a helicopter where you can touch the seats and equipment, but it doesn't look at all like what the helicopter would look like. So the way they deal with that is they put on a virtual reality headset in front of your eyes, and then it looks like the helicopter, and then you can even see outside. It's as if you're flying around, and then when you go ahead and sit down, you can sit down on the real seats. So essentially it's using the real environment for you to be able to touch and interact with, but you're overlaying the virtual visuals on top of it to make it look like the real thing. And then when we have a look at HoloLens and Magic Leap, well, these are augmented reality headsets. You're still mixing reality and virtual objects together, but in this case, the virtual objects you can't really interact with. They're just basically ghosts. Now, I'm jumping around here quite a bit. If it feels a little bit overwhelming right now, don't worry. I guess the whole point of this is to try and give you a quick overview of what's actually out there. But the main thing is I wanted you to appreciate that the field is actually super big, and it's okay to feel a little bit overwhelmed. So let's pull it back a little bit. Now, this list doesn't actually include every kind of interaction. We can already be assured that it's actually not as big as the entire universe. So for us in this unit, we're only interested in immersive experiences. So let's go ahead and define what are immersive experiences to us. And a good starting guide phrase is not just on the screen. This lecture, for example, is not an immersive experience. I mean, no matter how much I try to reel you in using my charismatic voice, your experience is still moderated by a screen. So you might be looking at this on your laptop or your phone. Please don't look at this through your phone. I recommend you just listen to it on your laptop, because you can have notes and everything on the side. And you might even be typing up a question or a new forum post or something like that. You can't really do that very easily on your phone. But anyway, it's not an immersive experience. But if we were in a classroom, that would be an immersive experience, because we're talking to each other, we're seeing each other, we're seeing unconscious cues. You can see my facial expressions, body language, and that kind of thing. So essentially that situation would be perceptually all-encompassing. So basically, if you have something that's surrounding you and you're in an environment, an immersive environment, then let's say that's an immersive experience. Now, another example of that would be a restaurant. You walk in, you meet the maitre d', you talk to them, they take you to your seat, and then you do your ordering, and then eventually when the food finally comes, you can smell the food, and then you can kind of feel it, you can touch it. It's perceptually all-encompassing. Now, if we compare it to just listening to a recorded lecture on a computer screen, you see it within the computer screen, you might have some other things playing around it, but outside of the computer screen, it's still the real world. It's not really related to what you're experiencing. And when you're dealing with a system like Moodle, which isn't very, very intuitive despite all our efforts, yeah, it's not an immersive experience. So let's stop to define this word affordance. You might have heard some academics use this term. You may not have come across this until now. And essentially an affordance is an ability that we give our user to be able to do something within our experiences. So in the case of Moodle, an affordance would be perhaps like a link that you can click or a text field that you can type into. One really, really important affordance that Moodle provides is the ability to submit assignments. But that's not generally natural. Clicking boxes and opening up menus and that kind of thing, you don't really often experience that in the real world. So that isn't an immersive experience. Whereas in the restaurant example, being able to talk to people, being able to touch utensils and eat food and smell things, those are natural affordances that we give to people. So a good guide phrase for intuitive affordance would be doesn't need a manual. So if an experience is perceptually all-encompassing and it has intuitive affordances, let's consider that to be an immersive experience. Now you'll notice that I didn't actually mention any headsets during this explanation, so it's not really just about fancy headsets. Although it is possible for us to consider things that are delivered through headsets to be immersive experiences. So for example, let's say a game like Death Unchained, which is a game that I've been playing quite a bit on the Quest 2. Well, it's on a virtual reality headset, like don't see anything else outside of the environment. If I look around, my view changes as I would expect it would, as if it were real. I get a certain sense of depth, I get a certain sense of presence. It's perceptually all-encompassing. It's a bow and arrow game, so instead of me looking at a screen using Xbox controllers, I'm actually pulling my hands back and releasing arrows and then dodging the projectiles coming in and that kind of stuff. It has intuitive affordances. Let's make a distinction between screen-based experiences and immersive experiences, which is what we're trying to design. And we want to make this distinction because the requirements for creative immersive experiences are a little bit different to what you would usually need to do with just flat two-dimensional screen-based experiences. Okay, so now having said that, well, immersive design, making immersive experiences is actually a very interdisciplinary medium. And when you think about like anything that's required to actually create an immersive experience, you can see that it covers all these different professions and fields. So I'm super biased. I have application developers up here because I am one myself. But if we look down this list, which is very incomplete, we have other people on the complete other side that has nothing to do with programming. So we have writers, we have people that create 3D assets, we have even architects. So if you look at architecture in particular, that's a really, really old field that's thousands of years old. So immersive design has actually existed well before all these headsets that have come across just recently. Now, our field being interdisciplinary like this, you might sometimes come across some clashes. So every different field have their own different language, I guess jargon. Gotta try and reconcile some of these differences to be able to work together. So as a general approach, I would say let's just be open and not start fights about how a certain word should actually be defined. Instead, ask questions, clarify. Usually you'll find that asking these questions will give you a better appreciation of the context in which they arose, and you'll end up with smoother dialogue with whoever you're working with. So for example, the word simulation for a computer person like me immediately makes me think, well, it's a computer simulation. So you're doing computational fluid dynamics, or trying to simulate how an aeroplane would actually fly in the real world, or simulating weather systems. But for someone doing simulations for, let's say, medical emergency scenario, that means blood or fake blood, actors and scripts and that kind of thing. And both situations is about immersive design. So let's not be too possessive of particular terms. If we ever get a little bit confused or a little bit overwhelmed, let's think about this model. So we have the user in the middle, because we're using user-centric design. And then you can see in any immersive system, we need to be able to know what that particular user is doing. So if you're in a game inside a virtual reality headset, you need to know if they're flailing their arms, then you need to know what they're looking at. So that would be dealt with the head tracking and then the hand tracking. But it also applies to restaurants as well. So instead of technical things, then the user state tracking for a restaurant could also be the staff, the waiter, the maitre d', and that kind of thing. So anyway, let's take the user's state and then feed that information to some kind of interaction control system where we decide what to do with that information. That would then produce a reaction from the immersive system, which would then be given to the user, and then the cycle sort of begins anew. That's the distilled version. If we were to keep going down the line, we can see that it gets a bit more complicated. So you can just read through this yourself. I won't go through the whole thing, but to try and make it a little bit more digestible, let's have a look at some examples and how this interaction cycle applies to these examples here. So we can have a look at real life to begin with. So then dining at a restaurant, and then this thing called live action role playing. So let's begin with the real life, because that's what we've evolved with, and that's what we experience the most and we're mostly familiar with. And then we slowly jump on to progressively more artificial things and more complicated things conceptually. Let's see how we go. Now let's look at restaurants as they fit into this interaction model. Now I chose this restaurant example because it's a very common experience for everyone. Now I've never been responsible for designing restaurants, but I have gone to thousands of them throughout my lifetime. So I hope you'll agree with me when we look at all the different considerations that a restaurant designer might look at and say that it is an immersive experience, because it isn't really just about the food, it's also about the decorations, the venue, the ambiance, maybe the uniforms of the staff, even the design on the menu. So let's look at some examples of how this interaction might occur. So we walk up to the front of a restaurant. Maybe it's like somewhere fancy in Chinatown or something, and you have someone in front that greets you. Maybe I think the proper term for that person is maitre d' or something, and this person greets you, and then you say, "Hey, table for two," or something like that. That information gets received by that staff member, and then it then goes back to the interaction control system. And then in this case, the interaction control system is the training that the staff member got and the rules of the restaurant. So the rules of the restaurant would say, if someone says table for two, we talk into the radio and ask, do we have a table for two? And then someone says, yes, we do, it's over here and such a table. And then the system decides, in this case the restaurant decides, okay, we're gonna seat you in this location. And then the maitre d' leads you to your table, and then you get seated. So does that kind of make sense? If we go back to our definition of what an immersive experience is, it meets the requirements, the restaurant I mean, because it's an immersive environment. It's all encompassing. You smell things, you see things, you taste things even. You're not just looking at a screen, like it involves all of your senses, and you feel like you're really there, because I guess you are, because this is reality. And if you look at what you can do, which in that situation, like I guess these are the affordances, they're very natural. So one of the affordances is you can talk to staff members and they react like they're real humans, because they really are real humans. So it meets the requirement for intuitive affordance. Now let's just do one more example. Now this time with the specific components made more concrete and relevant to the restaurant context. So now let's say we have everyone seated down, and then we've decided to pick what we want to eat. So then we talk to the waiter or the waitress or whatever, and then we go, this is what I want to order, and then they take your order, and then it goes back to the interaction system over here again, and then we now have the information of our order that gets sent to the kitchen. And then eventually you might have different reactions depending on what's happening. So you could have a situation where you've ordered something really popular and they've run out of ingredients. Kitchen reports back saying, we've run out of ingredients. And then the staff would then tell you, you've run out of ingredients. They've run out of that particular thing. You need to order something else. And then the whole ordering happens again. But if it's a happier circumstance and there are all the ingredients available, then you end up getting your food. You eat your food, you're all happy, maybe you want to go pay, and then you tell the staff member that you want to go pay. You get given the machine to pay, and then it goes up here. Maybe you have a linked external system here. I guess in this case it would be the bank, and then it goes back here again. Hey, your payment's successful. You have that conversation. So it doesn't really happen exactly like that, I guess, but hopefully I'm painting the picture that the example of the real world restaurant fits the interaction cycle like this. And if we were the designers of the restaurant, most of the stuff we have influence over would be around here. Now at this point I really want to ask if this made sense to you, but since you're not in the room with me, I'll just ask you to send me an email if it doesn't, to ask for further clarification, or you can ask this question during our concurrent class this coming Wednesday. So you might have seen some examples of this in popular culture. This is basically where a bunch of people go out into the forest or some kind of appropriate venue and pretend to be in a fantasy world. So this meets the requirements for immersive experience because that's all-encompassing perceptually, and also the affordances are intuitive because it's real life basically. There are some rules that you need to go by, but you can naturally talk to people, you can swing weapons, you can do lots of different things. That's natural. So if you compare this to a computer game, for example, let's say in an Xbox game, you would press a button to be able to swing a weapon, but in live action role-playing, you just swing a weapon in real life using your hands. Now let's see how the specifics of live action role-playing fit our framework. So if we move on to the next slide, we make the different little components become specific to live action role-playing, and we can see that the user state tracking is just other players and maybe some kind of dungeon master or something. So for those not familiar with what a dungeon master is, you might ask, hey Matt, what's a dungeon master again? And if we were in a real class, I would try to explain. But since you're listening to a recorded lecture, what I would suggest maybe is to go to the slide, highlight the term that you need a bit more clarification on, and literally just go Google it. And essentially a dungeon master is just someone who moderates the game to make it more fun for people to play. And the advantage here is because the dungeon master is human, they're able to much more effectively make it more interesting for the people involved, as opposed to just like a rule set in a computer game, for example. The specifics of the Dungeon Master isn't really the most important thing here. I just want to try and fit the context of live action role playing into our interaction model. Hopefully this is getting a little bit less scary, because the idea with these examples is to see if you can try and fit other situations into this particular model to make it so, in a sense, the interaction cycle then becomes an anchor point for all the different immersive systems that you might actually see. So then it's not so scary, with all the different aspects that they all have, because they all fit a certain pattern. So yes, live action role playing, you do something, maybe you say something to another player. These other players would refer back to the rules of the game to decide how to react. They do that reaction, and then you get that reaction as the user yourself, and then you decide how to react to the reaction, and then it sort of goes back into here. And you can see that it's moderated by this, interaction system here, which is the quote-unquote game. Okay, so in both the restaurant example and the live action role-playing example, the user actually isn't physically restricted from doing things outside of the rules. There are disincentives for not following the rules. So for example, if someone just came into a live action role-playing game and they were not keeping to the roles, so basically just let's say the game was about medieval magic or something, and then someone comes in and says, oh, I've got a gun, people won't like that, so you might end up getting banned from the group. So it's a disincentive playing outside of the rules, although it is still physically possible. In more extreme examples, if you go back to the restaurant, you can actually start being rude to the staff, or you can even take a plate and then start breaking it or throw it at people, or that kind of thing. But that's like really, really bad, and you could get the police called on you. So in these real world examples, as designers ourselves, we can take some things for granted, basically, physical, societal rules and things like that. As we move away from the real environment to the virtual environment, we need to be more rigid. And we can see that in our next example, which is a 1970s tank simulator. So this is what people actually used to train tank crews back in the 70s. And I really love this example because this is before we had all these advanced computer graphics to generate virtual environments, 3D objects and textures and particle effects and things like that. They literally just had some miniatures, and then to go around the environment, they had like a little camera fly over a bunch of miniatures, and that was their virtual environment. And it's really cool to see that it still fits our interaction cycle. So if we just move on to the next slide and have specific items for this particular example, we put the trainee inside a little tank room that's pretty close to how the real tank would actually look. And then they had knobs and levers and wheels and things like that as the state monitoring systems. I guess you also had like the trainer looking at what you're doing as well. And then you would take all that information, what you're actually inputting into the controls and what you're actually doing, and then put that into the simulator. And then depending on the state of the simulator, the location of the camera, or the rules of the specific training program, then you would get outputs back to the user. So these outputs could be like the trainer saying, hey, you've done that wrong, or like you've lost these many points or something like that, or let's say you pulled the trigger or something, and then you'll get like an output of the gun sound shooting. And I guess even in the case of just driving, so what you're actually doing is you're driving the location of the camera. So you would influence the simulator with the physical controls of just like the steering wheel. That would then go back to the physical control computer that regulates where the camera is moving on the miniatures, and then that would then go back as a live stream on the TV that you're seeing inside your room, and then depending on where it leads you, you would then maybe like turn left or right or something like that. Hopefully this is starting to make sense. So like in the last 3 examples, we've basically taken this structure and fit in all the different aspects to it in different locations. Even though immersive systems have all these different components and they all come from different fields to create the different components, they all come together in this context, in this kind of framework. Now, if we compare the tank simulator to the previous 2 examples, it's a lot more restrictive. So if you're only able to drive around within the environment that's been created, you can't go beyond it. In fact, I would say it's a bit of a step back to the previous 2 examples where you could actually do anything you want because it's more in the real world. This begs the question, if we're designing immersive experiences, why don't we just stay in the real world? Why do we have to bother with analogs of the real world, like virtual things? And the answer to that is it's a lot easier to control virtual environments. I mean, in the 1970s tank simulator example, you could actually contravene that or improve on that by actually really using real tanks. Then the risk goes up, right? And also the cost. So in that situation, you would need to buy real fuel and run real tanks, and then there'll be real safety considerations because people would for real hurt themselves in this big massive metal thing. You could run over people, or you might even just get stuck inside some of the mechanisms while you're inside. If the trainee were to run over something or even someone, that would be really, really bad if it was done in real life. So if it were done in a virtual environment or a non-real analog, then the costs of making mistakes is less. So as designers, there's a balancing act that we need to try and do. Real life gives us basically free, realistic affordances, free intuitive affordances, because that's where we exist as humans. It is naturally intuitive to us in the real world because there's not really any jump. But that's the problem, there's no real jump. So anything bad that happens in real life also really happens in real life because it's real life. I hope that kind of makes sense. Whereas in virtual environments, you have to make a little bit more effort to create the virtual environments, but the mistakes that happen in the virtual environments happen in there, so it's much more controlled. The tank example is, I guess, a semi-virtual environment because we're using miniatures. It's a physical analog. It's not exactly a real tank. It's not exactly real life, but you still have physical objects. So then we can have a situation where we can use fully virtual environments and still have a comparatively rich experience. So it's still all-encompassing in terms of your senses, and it's relatively intuitive in terms of affordances. So let's take the example of Microsoft Flight Simulator in virtual reality. You put on a headset and you also have these nice controllers. It still fits our interaction framework, but now when we compare all the different elements, like all this stuff here, these are all digital. So if we go back to our tank example, these are physical objects. I guess like this is kind of a digital thing here, but this is still a physical computer control system. It's not like a cloud system or anything like that. Whereas this stuff is all happening inside your computer and it gets rendered inside your computer, and that doesn't really affect the physical world. This guy is physically controlling the motion of this camera over a miniature map. So, but you can see that it still kind of serves the same purpose, right? So if we go back to our interaction cycle, we have us as the player. We do something to the joystick physically, and then we look around with our headset to keep track of the head position. This then gets fed back to the simulator. The simulator is taking into account the data coming in from Bing Maps to be able to generate the terrain that you're looking out into. And then it also has its own weather simulator. And then that's all generated to all this then interact with all the different digital assets that exists within the game. It gets told where to position the buildings using big maps and all that. It gets told how to render the weather. So anyway, like that's the interaction control system, and then all that stuff gets fed back onto the headset display. If you have a nice force feedback joystick, then it would also tell your force feedback joystick how to react. That gets all fed back to you, and then you react to all of that, and then the cycle continues. So it's the same idea, but the difference is that you're no longer restricted to the miniatures. You can go anywhere in the world because you've got big maps. You can change the weather because it's just a digital simulation. If we go back to the tank example, if you wanted to simulate fog or rain, you would actually have to physically create the fog and the rain so the camera can see it. Whereas in the flight simulator example, you just need to put this onto the screen or into the headset display. So I think I've been talking for close to 40 minutes now, and that was my original budget for this lecture. So I'll go over time a little bit. The next two examples I want to have a look at, I won't explicitly put in the context of the interaction cycle. So I'll leave that with you guys. So let's take the example of Pokemon Go. Now in the reality virtuality continuum, Pokemon Go would be around here somewhere. I'm assuming that everyone's familiar with Pokemon Go because it's a very popular game, but I just wanted to break it down a little bit more than what we would do if we were just casually observing it. So the thing to note about Pokemon Go is it actually tracks the real world environment and overlays the virtual objects on top of it, the Pokemon. That's actually something interesting. So I've been playing Pokemon Go since it came out, and I can see that it improved quite a lot since the first version. Now in the first versions, the Pokemon would just be overlaid on the screen without any knowledge of the local environment. So basically if you were to move your phone around, the Pokemon would still stay in the same location on the screen, whereas the current version now, it actually looks like the Pokemon is in your environment. So if you moved your screen around, you would see that the virtual objects would stay on the same location on the floor. It wouldn't actually just be like a simple overlay. So I just wanted to point out that technology or that capability is enabled by something called simultaneous localization and mapping. And that's a technology where the device itself is able to scan its environment and know its actual location within that local environment. And it is this information that it uses to be able to rotate and scale and position the virtual objects so it looks like it's on top of the real ground or the real environment. Now here's a little question for you. It uses your phone screen as the means of interaction. So we're kind of breaking the rules here a little bit. If we go back to our definition of immersive experiences, it's kind of trying to shirk the intuitive affordances definition, because if it really were intuitive, we would be using our hands to interact with the world. So, like, why would we even bother with this? So I guess this is something to contemplate and discuss during our concurrent class. Why bother with applications like Pokemon Go? Now I'm going to skip this slide because we're running out of time. You can have a look at that yourself. So my challenge for you guys is to try and see if you can fit this into the interaction cycle, which specific components would actually go into what part of the interaction cycle, but I'm gonna skip that. Let's take a bit of a break and try to take in all the stuff that we talked about just now. Let's also skip the discussion about HoloLens. We can pick this up again in our face-to-face class, concurrent class. And if someone wanted to start a discussion in the forum, that would be awesome actually. We can talk about that. But let's try to wrap up and summarize. Maybe let's not worry about these 2 points up here because we would need to have talked about HoloLens and Pokemon Go and the other example, hyperdimensional friends. But hopefully you already have some inkling that these two have something to do with all this stuff. So maybe that can be something you can think about for homework maybe. But for now, for this lecture, I just wanted to reassure you that you don't need to be able to build everything yourself. Even though immersive environments and immersive design needs all these people, we don't need to be all these people. We just need to be able to know how to take all the capabilities of all these people and set them up in a situation like this. And yes, it definitely gets complicated, especially when we get to the specifics of everything. But as long as we have this foundation, we should be able to have a good anchoring of what to do. Now, speaking of specifics, you also don't need to know every single thing that comes out. You just need to know what's gaining prominence. You can't possibly keep up with everything that's coming out now. So if we go back to this example here, there's like a whole lot of stuff that's coming out now. You just need to be able to situate it in this particular context. And then if we could relate it back to this context here, so a nice piece of technology might relate to user tracking or maybe sensory feedback, or it could be something to do with the interaction system. So if we go back to these slides here, I don't talk about any specific technology, but for all these different categories, there are lots, and there are lots here, there are lots here. But if we stayed anchored in here, it shouldn't be so daunting. So we'll talk a little bit more about brain-computer interfaces and other more detailed things in modes of interaction B, but that won't be until week 5, I believe. So for now, let's concentrate on this and this. So summing up, our examples didn't start out with fancy schmancy headsets and all the tech. So don't think about the tech first. We want to think first about what we want our users to experience. So when someone was designing a restaurant, for example, they didn't necessarily need to have headsets on people. It's all about the food. In the case of the 1970s tank simulator, it's all about the training. But in that case, we don't have unlimited resources to run over obstacles and damage physical objects, so we just settle for fake damage and non-real physical objects. I guess in that case, those are miniatures. So I guess back then, they didn't really have nice computer graphics or something with enough fidelity to be able to reproduce the environment that tank people would be operating in. So they opted for a camera and a whole bunch of miniatures where the camera is being controlled by a rudimentary computer. Or it was pretty advanced for back then, but I guess it didn't have the same kind of computer simulation technology that we have now. Yeah, so experience first, and then I guess your physical restrictions, and this is moderated by the budget mostly, and then from that you'll be able to find out what you have available to be able to implement what your user experience is. Hopefully that made a little bit of sense. I'm gonna end it there. Like I said, it's quite challenging to just be talking to a screen without any feedback. So please, if there were any confusing parts, post it in the forum, send me an email, and then we'll discuss it in class. Okay, thanks for listening. See you in class.